Good afternoon, guys, and we are back with today's problem of 29th August 2021, and the problem is from sufficient statistic. Okay, this is a really interesting. It's a very straightforward problem. In fact, you can find a textbook problem, but this idea of how to prove sufficiency is really dependent upon this idea that will be used in this problem. Okay, this problem-solving idea that is used in this problem, and it is called name and factorization theorem. And so let's get accustomed to it and let's see how what is the proper logical thoughts behind it, because when you will write it in ISI, I mean you can do it easily in IIT Jam, but when you write it in ISI you need to write the proper logic, and more importantly it should make sense to you logically, to your inner self. So that is much more important than any other exam though. So let's get an understanding of how to solve this problem. Okay, and before that, if you have not solved this problem yet, please stop the video and don't see the solution now. Okay, and yep, so solve it yourself and then come back to the solution. That's my first step. So pause the video, come back to the first, or if you don't want to pause the video, you can go to the description. There is a link below, okay, and of the problems. You can go there and check out the problem, and then you can come back and see the solution. So all the best, guys. Let's get started. Um, Perfect. So let's understand how to solve this problem, and let's understand. We need this idea of name and factorization theorem, which gives a characterization of sufficiency principle. I have taken a screenshot from Wikipedia. So what is the result we are going to use? Just give me a minute. My tablet is not working. Let's check. Okay, so what is the in the meantime my tablet starts working? What is the main idea behind this? Main idea behind this is what is sufficient statistic? What is a sufficient statistics? You must know that. So a sufficient T is called a sufficient statistic for theta. It's very interesting in the sense that T contains every information about theta. T contains every information about theta. Every info about theta probabilistically. So if that is the case, then what you can see over here is this, that therefore T is also random variable because it's a function of the given data. So xi, x1, x2, xn are the data. Okay, so your aim is to find the statistic T, which is a function of this, which is again a random variable, such that this is a sufficient statistic for theta. So what does it mean in a frequent test manner? It means that probability of the data, that is x1, x2, xn, given this T, this another random variable T, is given the information of T, this data has no information about theta. That means this, like if this continuous, then take joint PDF. If this is not a continuous, then take joint discrete. So whatever it is, F or PMF, like PDF or PMF, this is independent of theta. Of the parameter theta. That means that this T contains, given this information of T, that means this T contains every information about theta that is being encoded over here, this probabilistic statement. And as an application of this definition of the sufficient statistic, we can actually prove by very simple step that a sufficient statistic, like like f can be written as by conditional probability. Any f can be written as a sufficient statistic, a function of the sufficient statistic into the h of the data, the x. Okay, so this is the basic idea, and we will try to prove. So how to use this to find the sufficient statistic? We'll try to express the joint density of the entire data in terms of this. Okay, in terms of h of x, h of the data part into the h of some g of some tx. So we have to identify that tx. Okay, and this is a very important problem solving strategy. So understand how we do it very step by step in a very skillful manner. So stay tuned. Okay, so yeah, let's come back to the problem. So we are given a data from x1, x2, xn from a random sample uniform theta1, theta2, and we have to show this is sufficient statistic. Okay, which is this. But let's not think about this. Let's think about how we can write. The first step is how to write the joint distribution. Write the joint distribution. write the joint distribution. If you write the joint distribution, you will see. So xi or IID, xi follows uniform 0 comma theta 1, or what was it, theta 1 comma theta 2. So you can understand that maybe the f of xi of x, let's say xi observe small xi, is 1 by theta 2 minus theta 1. Okay. There is an indicator random variable. There's an in given the condition that this xi is less than, given the condition that is xi is less than equal to theta 2 and greater than equal to theta 1. This is a condition. If that means it's telling that it's same as telling, so we write how? We write like this, now. We write a PDF like this. If xi less than equal to theta 1 or theta 2 greater than equal to theta 1 and 0 otherwise. So to instead of writing this extra statement, what we do is that we write it in terms of indicator random variable. Okay, and we delete this part. We delete this part and we write it as 1 minus theta 2 minus theta 1 indicator. The idea that we don't write in a very compact form. Theta, sorry, yeah, xi, the observed value is less than equal to the maximum value and greater than equal to the small value. That means agar it remains inside this, it will be 1. If it's not, then it will be 0. That's it. Simple stuff. Very beautiful, very crispy, and very to the point way of expression. So this is how we write it. So that's for one variable. So we need to find out the joint distribution now. So therefore, PDA, the joint distribution of x1, x2 dot xn of small x1, small x2 dot small xn. If you write this, you will get that it's equal to, they're all disjoint, they're all independent. So it's probability multiplication of I from 1 to n, f of xi of small xi, capital Xi of small xi, which is equal to pi of 1 to n 1 minus theta 2 minus theta 1 into indicator what, xi small xi less than equal to theta 2 and greater than equal to theta 1, right? So if you multiply this, the understanding you are multiplying 1, so it's like this, indicator into of set A times indicator of set B means what? It means that it's equal to 1 if A occurs and 0 otherwise. It's indicator if B occurs and 0 otherwise. 1 if B occurs and 0 otherwise. If you multiply, what we'll get? It's indicator if A and B occurs, that is A intersection B. This is equal to indicator of A intersection B. If you can't understand, stop the video, understand this. This is a very important idea. And similarly, when you multiply these indicators, so you get here 1 minus theta 2 minus theta 1 whole to the power n. And here you get that indicator, all this thing will hold true, right? So therefore, indicator, each of the xi's are greater than equal to, each of the x1, x2 dot xn are less than equal to theta and greater than equal to this. So this is the main idea. And we can write this information. We can write this beautiful information in terms of two random variables, two order statistics. That's why we read order statistic. So understand that telling that a set of numbers, understand this very carefully, close your eyes and understand. This statement that a set of numbers is between 5 and 3 is same as telling that the set of numbers between 5 and 3, the set of numbers between small theta 1, small theta 3 is same as telling that indicator, the minimum, that is small order statistic, is greater than or equal to 3, that is theta 1, and the maximum order statistic is less than or equal to 5. It's like telling the set of numbers lies between 3 and 5 means the minimum is greater than or equal to 3 and the maximum is less than or equal to 5. That's an equivalent statement. That's why I write in terms of this, right? So we have written the joint distribution. Let's write joint distribution very clearly. We have written joint distribution f of x1 comma x2 comma dot xn in terms of in terms of indicator x1 greater than or equal to theta 1 and xn is less than or equal to theta 2. This is what we have written at. So let's try to understand now So we have to express, to find the sufficient statistic, we have to express it in terms of h of x times g of theta. Maybe I'm doing some error. Yeah, h of x and the g of theta of tx. So to find this tx, okay, you can write this x1, small x1 and small x2. Sorry, this small x1 and small x2, not capital X1, capital X. This is a mathematical mistake. Yeah. Okay, and now understand that here, to understand this very carefully, that h of x is actually equal to 1 times this is h of x times this g of theta of tx. Now, what is this tx? Therefore, you can understand that it can be written as a function of 1 times g of theta of small x1 random variable and small x2. You see, if it was, sorry, small xn. That is, it can be written as a function of x1 and x, like the maximum order statistic and minimum order statistic. Therefore, x1 comma xn is actually a sufficient statistic for theta 1 comma theta 2, this pair, in this case, by using Neyman factorization theorem. So this is a super important idea, and if you don't understand, if you have not read sufficient statistic, please make sure that like you know sufficiency, why this intuition between by and sufficiency, why it's important, and this is a way of proving sufficiency. So all the best, guys, and yep, I hope you enjoyed that. It's a very basic problem, but it was meant to for those whose sufficiency principle was not clear, and how to prove sufficiency in the most of the cases. This is the most important way, like most important logical way. All the steps should be written like this, okay? Otherwise, the logic is not totally clear to you. So this is how you should write. Yeah, that's it. So all the best, guys, and yep. So if you enjoyed it, do like, share, and comment, and subscribe to the channel for more such problems every day. And yeah, if you, okay, by the way, there is something like from October, if you're seeing Avinav Shukla's lecture, okay, so of how to prepare for IIT Cham, he has told like one should prepare well at least before 3 months. So from October, that's why Cheenta has started some crash courses for you guys, a very minimal cost. So you can check out the crash courses, and crash courses are really beautiful aspect of crash course are the mathematics, statistics, or like probability. You can choose any one of them, okay, not all of them, according to your own need, and that's the beauty of it, okay. So you can choose any one of them, and yeah, go ahead and enjoy the problem solving yourself, or yeah, and enjoy. All the best for your exam. See you in the next video. Stay tuned and stay blessed. Bye bye.